Hello everybody, hope you're doing well. My name is Mahmoud Kiosari and this is Special K. So today we are going to move on into another subject. Like the previous videos that you can some kind of look at through the YouTube channel, we were talking about four basic arithmetic operations. So right now we are trying to dive a little bit inside the topic itself, and we are going to start the work with the fractions. Okay, let's get started. Fractions. First of all, let's start from the basic things. That what is the definition of fraction? When we do have a smaller part of a whole number, again, you guys remember what was the whole number, right? The whole number, any number like 2, 3, 4, 5, 6, some kind of positive infinite, would be considered as a whole number. If we are trying to divide that whole number into small chunks and only consider having specific number of chunks, we are saying that we're using the fraction. So the smaller part of the whole number written with one number over another one, which we call one number on the top as numerator and another one on the top as a denominator. So when we are writing down the number like this, it means that I just divided down a piece of cake that was in 8 divisions or in 8 chunks, and I only considering to have 3 of that. So this is the definition of fraction. So any number that is smaller than 1 is going to be considered as a fraction, and either we write it down like 3 over 8 or another form 3 over 8. Again, this one, sometimes this line is going to be considered as division. So I mean that's some kind of definition of fraction again. So if we can write down any number like this, we say that we do have a fraction. So again, you can think of it that when we are talking about 3 over 8 as 3, you can see that 3 of 8 parts. It means that I do have a cake. I'm going to divide it down into 8 parts, and I'm only going to consider only 3 of it. 11 over 16, it's just 11 of 16 parts. So here's another thing. As I just told you, if I can write down a whole number or some kind of number into a form that the smaller number is going to be on the top and the bigger number on the bottom, we do have a fraction. But also we do have a fraction in another form, which could be a bigger number on the top and a smaller number on the bottom, something like this. 24 over 6. Again, it's just like the division. It's just like fraction. Why? I do have a number on the top. Let them call it as a numerator. I do have a number on the bottom. Let's call it as denominator. And after that, I do have a line. So I still can do that. But here's the question. What are the exact numbers that can be written as fraction? So right now, the first answer for this one is that any number or any whole number can be written as fraction. So you heard it right, folks. It means that if I do have 4, I still can write it down as fraction. But here's the question, how I can do that. So let's look at this, some kind of simple example over here. Imagine that I do have 4 as a whole number, right? So I'm asking you to write this down, this number, into a fraction by considering the fact that 4 should be divided into 6. What does that mean? It means that right now I do have a whole number as a 4. So obviously, if I want to some kind of convert this number to 6, means that I do have 4 slices of pizzas, that each of those pizzas are divided down into 6 pieces. So here's the thing. I want to some kind of make it a little bit understandable for you. Are you agree with me that 4 multiplied by 1 is still 4? Because obviously we know each number multiplied by 1 is going to be itself. And are you agree with me that 6 over 6 is actually 1? It means that 6 divided by 6, 10 divided by 10, 20 divided by 20, it still is going to be considered as 1. So would it be okay if I say that instead of this 1 that I have for this question, I'm going to replace it with 6 over 6? What would happen? We are going to talk about this, some kind of multiplication of fractions. But right now, just accept it that 4 times 6 over 6 is going to be considered as 24 over 6. What happened right now? At this point, I know I do have 4 pizzas that each of them has 6 slices in them. So I can say that actually I do have 24 slices of pizzas. Why do I have this 6? This 6 is going to show me that how many full pizzas do I have. So when you have a question like this, try to think about the pizzas. So at this question it asks to change the whole number is 4, to 6. It means that I have to divide this down into 1 over 6, 1 over 6, 1 over 6, 1 over 6. How many of these 1 over 6s do I have inside the 4? It is 24. How I can show that I'm looking for 1 over 6, 1 over 6, 1 over 6? By using a fraction at 24 over 6. So that was the definition of fraction, and that's how we can change the whole number into the fraction again. So let's just talk about different kind of example. Again, you have the answer. The one thing that I really suggest in this kind of condition is that pause the video, just for example, move the one like this, and after that, don't just look at the answer, try to do it by yourself, and then come back to see that are your answers right or wrong. So the question is like this. I do have a full number, 49, and the question asks to write it down in seventh. Again, imagine that you do have a pizza, and after that, you are going to divide it down into 7 slices. Each slice is going to be considered as 1 over 7, right? So I do have 49 full pizzas. It means that in each pizza, I do have 7 slices. So what would happen to the final one? 49 multiplied by 7 divided by 7. I believe you know better than me that how we can solve it. 40 as a whole number to 8th. I do have a pizza that it has 8 slices. Again, 40 multiplied by 8 over 8. I do have 54. I'm going to convert it to 9th. I do have a pizza that it has 9 slices. So 54 multiplied by 1 over, be careful about that, not 1 over 9, because 54 is going to be considered as what? As a whole number. So 54 multiplied by 9 over 9, whatever the number is, and so on and so forth. So right now, we just learned about the fraction, the pizza analogy, and how we can convert a whole number to a fraction itself. So let's dive down a little bit more inside the world of fractions, because we saw 2 different fractions. Again, for the first definition was something like this, 3 over 8. It means that a smaller number over a bigger number, but at another point I told you that 24 over 8 is going to also be considered as a fraction. It means that at this point I do have a bigger number over a smaller number. So we do have 2 different terminology over here. The first one is about proper fraction. What is proper fraction? When you have a point that your numerator is a smaller number than denominator, it means that something like this, 3 over 8 or 3 over 4, it means that we do have proper fraction. What does that mean? It means that we don't have to do any extra work about this one. 3 over 4 means that 75% of the whole pizzas. I don't have any whole number. I cannot do anything with it. I just leave it as the way it is. Another some kind of terminology that we do have is about improper fraction. The numerator is greater than or equal to the denominator. Something like 15 over 9 or 24 over 8. What does that mean? It means that at this point, my fraction is not just a normal fraction. That guy has a whole number inside of itself. So for instance, let's look at this number. I do have 15 over 9. 9 means that I do have a pizza that is just divided down into 9 pieces. So when I do have 15 over 9, it means that I do have 15 slices, right? But I know each 9 slices is going to make one full pizza. And after that, whatever left, which is going to be 6 slices, can be written down to something like this, 6 over 9. So I do have a whole number. I do have a fraction. So we just learned that if I can divide down my own fraction into one fraction and a whole number, I will say that specific fraction is improper one. So which is going to lead us to the next part as a mixed numbers. Combination of the whole number and a proper fraction is going to give us as a mixed numbers or improper fraction. So here's the question, that how I can change this mixed numbers to fractions. So this is the important part. I do have 3 pizzas and I do have 7 slices, like this question, which is, I'm going to write it down like this, 3, and just beside of that, I'm going to write down the fraction. 3 as a whole number, 7 over 8 as a proper fraction. So right now I'm asking you that how many slices of pizza you have. What you have to do, the only thing that you have to do is like this. Divide it down into two chunks. 3 as a whole number, 7/8 is just a fraction. So if you remember, if I'm going to convert a whole number into fraction, at this point we are talking about the pizza that has 8 slices. I can multiply this guy by 8/8. What does that mean again? 3 times 1 is 3. 3 times 8/8, again is 3. I'm not changing anything about the question. Guys, remember, if you're trying to explain a question, if you're trying to change the question, you have to make sure at the end you are not going to add something to it or subtract something from it. At the end, still has to be like the question itself. When you have a 3, I don't care, you make it like 3 plus 1 subtracted by 1. At the end, I have to keep the 3 for myself. Just like the way that I'm doing over here. 3 is actually can be written down at 3 times 8/8, which is 24/8. Okay, that's a good one. I do have 7 slices out of the pizza that can be divided down into 8 slices. I do have 24 slices, and right now I can add them up. 24/8 plus 7/8, that I do have it at 31/8. Again, we will talk about the adding in some kind of fraction, subtracting, and multiplication, don't worry. But here's the way it is. So what does it say? It says that instead of just writing down this number as 3 whole number and 7 slices, or 7/8, or 7 of 1/8, I mean 7 of 1/8. 1/8, just some kind of repeated 7 times. So right now I do have 31 slices of a pizza that was just divided down into 8 pieces. So we do have it at 31/8. Simple. This is the way that you some kind of converting the mixed numbers to fractions. Again, so we do have proper and improper fractions. We do have the mixed numbers and how we can convert the mixed numbers to that. So let's look at another kind of questions. Again, try to do try to do this way. Try somehow getting rid of the answer. We just have all the questions. Look at them. Just pause the video. Do them for yourself, and after that, come back to see that where was your problem. Okay, guys. We are working on a subject. It doesn't matter. This is math, physics, chemistry. It would be about more advanced electrical circuit control, whatever it is that. Try to think about the questions and try to answer it and define each question based on your own words. It doesn't necessarily mean that your answer is going to be right, your answer is going to be wrong. But at the end, you are learning something. First of all, understanding the concept, using your own words, going back to the answer again, seeing the answer, and after that coming back again, just understanding from your own word, and try to have an iterative loop for yourself. And at the end, I promise you, you can completely understand the subject, and in the future, you also can teach it. It's not that hard. Everything is simple. But the only thing that you have to do is just to understand it. So I do have 4 as a whole number, and I do have 1/2 or half as a fraction. The question is easy. It's asking to convert the whole thing into a fraction, or obviously improper fraction. So I do have a 4 as a whole multiplied by 2/2. I do have a pizza that it has 2 slices. If I do have 4 some kind of whole pizzas, how many slices do I have? 8 slices. I do have 1/2 as 1 slice. If I add them up, I do have 9/2. So at the end, I do have 9 slices. I do have 8 pizzas, and each of them has 4 slices. I do have 8 as a whole number, multiply by 4/4. I do have 32/4, and after that I do have 3/4. Add them up, 35/4. It means that at the end, instead of just having 8 whole pizzas, 3 slices, I do have 35 slices, based on the fact that I know I do have a pizza that only can be divided into 4 slices. So on and so forth. You can also understand all of the questions. Again, this is not that hard. The only matter of time is about the multiplication, which we did it for our previous videos. You can just look back. I did a full video about the multiplication. We had so many examples, so you can just look at them and make sure that you don't have any problem with this kind of things. 1 digit by 2 digits, simple. We just work on in our previous video we were working on 2 digits by 3 digits, and that's going to be a whole lot of maths. But don't worry about it. You can understand everything by just practice. Okay, let's move to another part. So we were talking about how we can convert a mixed number or some kind of a whole number with a fraction into improper fraction. What about vice versa? How I can do that? So if you remember from our division course, we were talking about how I can divide a number to another number. So it means that at this point I do have, for instance, 6 divided by 3 is equals to 2. I know that. In 6 slices, if I assume that each 3 slices are going to be 1 pizzas, at the end I do have 2 whole pizzas. But the question is not going to be simple at all the time. There are sometimes that we do have something that we call it as remainder. What is remainder? Imagine that I divide 7 divided by 3. So if you do that in a normal way, it would be what? 2.5. But here's the thing. Right now, we are only considering the whole numbers, the numbers without any decimals. So if I ask you to do this division, actually I'm asking you to find one number as a whole, or how many whole pizzas do I have, plus the number of slices. The whole number is something that I'm looking for, this one, that the name is just there as a whole number, and the number that we are looking for that is not going to be fit inside the whole one, and it's going to be a couple of slices, is something that we call as a remainder. Imagine that I do have 19 divided by 33. But for example, some of you would say that, okay, why we do need that? Actually, we are talking about converting an improper fraction to a whole number and fraction. Obviously, we know that most of the time, an improper fraction contains 2 parts, a whole and some kind of fraction once more. Is that so? So obviously, I have to find a whole number based on my division, and I also have to focus over what? Over the remainder, because that's an important part. The remainder is going to give me the fraction. So let's look at this example. 19 divided by 3, right? 19 divided by 3. In your mind, how many 3's, as if perfect 3's, do I have inside the 19? 3 times 6 is equals to 18. Cool. 3 times 7 is equals 21. I don't like it. So 18 is the answer. It means that right now I do have 6 whole pizzas inside 19 slices based on the fact that each pizza contains 3 slices. But here's the thing. How many more slices are going to be left? So plus 1. 1 is as a remainder. 6 is as a whole number. Here's the question. How I can write it down? So it's not that hard, it's simple. Again, if you remember, for the improper fractions, either we can write down the numerator over the denominator, which we know it as a bigger number or a smaller number, or we can write it down as the combination of 2 numbers, a whole one and a fraction. So at this point, what do I have? I do have 6 as a whole number, and I do have 1 as a slice. But here's the question. 1 over what number? If you remember, for this question, each 3 slices is going to be a whole pizza. Is that so? So when we are talking about 1, actually we are talking about 1 slices out of the whole pizza, which is 3. So right now, based on the pizza analogy, I can write it down as 6 and 1 over 3. Let's do the next one. 37 divided by 7. Again, remember, I do have a whole pizza that each 7 slices of that pizza is going to make the whole pizza. 37 divided by 7. How I can write it down? So I have to find a number plus another number, right? How many whole 7's do I have inside the 37? 7 times 6, 42. I don't like it. 7 times 5 is 35. That's bingo. So I do have the first number as 5. It means that I do have 5 whole 7's or 5 whole pizzas inside 37 slices. What is going to left? I do have it as 2. How I can write it down? Easy. 5, 2 over 7. 5 whole pizzas, 2 slices out of 7 slices. 44 divided by 4. Here's the interesting part. Because as you can see over here, 44 divided by 4 is equals to what? How many times of 4 do I have inside the 44, and how much is the remainder? I do have 11 perfect 4's inside 11. What about this number? 0. Is there a problem? No. Because if you remember, I told you improper fraction contains 2 parts, a whole number and the fraction itself. So what would happen if I don't have any of those? That doesn't matter. You don't write it down. Easy, right? So at this point, 44 divided by 4 is 11 without some kind of improper fraction. Can I write it down? It doesn't necessary. You have a 0, get rid of that because you're not going to use it, right? 0 is just 0. I'm not going to use that one. Remember, when we write down, for instance, 4 1/3, it doesn't necessarily mean that 4 multiplied by this number. Because some of you maybe know about some kind of the multiplication of fraction would say that, oh my God, I do have 11, I do have 0, so if I multiply them would be 0. Ta-da! No, that is not right. That is not the way that we write it down. We are just going to write them down beside each other. 11, 0. 4, 1/3. 5, half. Something like this. So let's look at another example. I do have 23. And after that, I do have it divided by 5. So how I can write it down? Again, 23 divided by 5. Try to convert the question to the thing that you like. I like pizza. That's why I'm trying to use the pizza terminology. How many times the 5 is repeated inside the 23? How many times I do have a whole pizza that each pizza contains 5 chunks or 5 slices? So probably I do have it as a 4. What is the remainder? 3. Easy. So I do have 4 as a whole number. I do have 3 as just remain slices. So what would happen at this point? I do have 4. I do have 3 over what? 5. Simple. I believe you can do all of them, and after that try to look at the answer. Again, try to go back to answer the question again and again and again until you make sure there is no problem about that. And if you have any problem, just put a comment for me. I will explain that specific question for you in details in a very short video. Don't worry about it. Okay, so we talked about it, that we do have fractions, proper fractions, improper fractions, but sometimes we do have a fraction that actually is a little big or it's a little bit unusual. What does that? Imagine that I do have 2/4. Imagine that I do have 3/6. Imagine that I do have 1/2. Let's use the calculator, shall we? So at this point, I would like you to use the calculator in the computer, in the phone, or you have a normal calculator, it doesn't matter. Do this kind of divisions. Let's see what would happen. 2 divided by 4, how much? 3 divided by 6, how much? 1 divided by 2, how much? Pause the video, do all of that. Okay. Did you see anything strange about it? I believe you did. All of them, the answer is half. The answer is half. The answer is half. So what is happening right now? It means that at this point, I do have 3 fractions that apparently all of them are the same, but which one is the right one? Again, there is no right or wrong answer for that, because at some points you need all of them, and at some points you need only one of them. Right now, I'm only talking about one of them. Imagine that you do have an example, 3/9. 3/9 is a perfect fraction, so it's a proper fraction. There's no debate about that. But I'm asking you, is there any way that I can write it down in a simple form? What does a simple form means? The simple form means that I'm going to reduce this fraction or some kind of make it smaller in a way that my final answer is not going to change, but I don't like the big numbers. 3 and 9, 10 and 12, 20 and 30, 100 and 200, they're a little bit big to me. I'm trying to convert it down to numbers that I like, a number between 1 or 2, 3, 4, denominator 4, 5, 6, something like this. I'm trying to reduce it to lower terms. This is a new terminology. When a question asks you to some kind of reduce a specific fraction to lower terms, it means that you have to find a way to rewrite the fraction as the way it is without changing the final answer. Do you remember I told you that when I do have 3 and I multiply by 1, which is going to be 3, I'm not changing anything. I'm just changing the way that I can write it down. 3 multiplied by 4/4, 3 plus 1 subtracted by 1. All of them are going to give you the same answer, but I'm changing the form. Why? Because I need it in the future. Right now, let's just have an agreement. I know that some of you would have some disagreement. Well, let's have some agreement about that. That if I can find a way to divide the numerator and denominator by one specific number, again, equal number, in order to reduce those two numbers or make them smaller, I do have a method, or I do have a way that is going to lead me to reduce the numbers to lower terms. So enough of talking, let's talk about this one. Oh, again, you're talking. So 3 over 9. The question asks me, find a way to divide 3 divided by 9 into a smaller form of fraction. So let's see. Would it be okay if I say that 3 divided by 1 is actually 3? It means that nothing happened. 3 divided by 1 is equal to 3. So at this point, 3 and 9, remember, I can change the form, but I have to make sure at the end, the answer that I get from the fraction is not going to be changed. 2 divided by 4, how I can convert it to a fraction that its answer is not going to be is not going to change. 2 over 4, half, 1 over 2, half. How I can do that? Find specific number that can be divided, but both of the numerator and denominator without having any remainder. Look at 3 and 9. Let's look at them. Do you see any special thing about those? 3 actually is just a 3 itself, but what about 9? Can I write it down as 3 multiplied by 3? Yeah, makes sense. So it means that I do have one common number between both of them, and that number is 3. What about 2 and 6? I can write 2 as 2. What about 6? 3 times 2. What is the common number between them? 2 and 2. I can do it right now. It means that if I just divide my 3 over 9, the whole fraction, 3 over 9 divided by 1, I'm okay, nothing has changed. But can I write down the 1 as a common number between 3 and 9? Would it be okay if I write it down 3 over 3? I didn't change anything, right? 3 over 3 is just 1, and 3 over 9 is just a fraction. At this point, we will talk about the division. Don't worry about it. We will talk about division. At this point, I can divide the numerator by 3. I can divide the denominator by 3. What is happening at this point? 3 divided by 3 is 1. 9 divided by 3 is 3. That's it. So at this point, I just converted 3 over 9 by 1 over 3. This is a very good way in order to check your answer. Again, remember, when we change the question, when we change something, we have to make sure at the end, my final answer is going to be the same. What does that mean? It means that 1 over 3, if you just use your calculator, you will see a number like this. 3 over 9, again, if you do that, you will see something like this. So it is right. I didn't change, yes, I changed the form, but I didn't change the final number. So everything right now is in good hands, reducing to the lower terms. But here's another question. Just before moving to the next part, to have some kind of example, reducing to lowest terms. What does that mean? Imagine that I do have 4 by 8. And some of you would say that, okay, I can divide the 4 by 2. I can divide the 8 by 2, and I do have the final answer as 2 over 4. This is right, reducing to the lower term. But can I keep going? Can I make it as a lowest number, try to find the numbers that I can't do the division anymore? The answer is yes. 2 over 4 can be written down divided by 2, divided by 2. 1 over 2. It means that 2 over 4 is a lower term. 1 over 2 is the lowest term. So these are two different terminology. 16 divided by 32. Can I divide it by lower terms? Of course I can. Why? Because both of them can be divided by 2 without any remainder. 16 divided by 2. 32 divided by 2. What do I have? 8 over 16. Can I do that again? Yes, you can. 8 divided by 2. 16 divided by 2. 4 divided by 8. Can I do that again? Yes, you can. 2. 2. Do that again? Yes. 2. 2. Do that again? No. This is the final step. So I just converted 16 over 32 to 1 over 2 as the lowest term. So far, we learned about the reducing fraction. We just learned that there are sometimes my numerator and denominator can be divided down into common numbers, divided down by common numbers in order to find some kind of the simple answer for them. Not all the time I have to keep the 3 over 9 or 16 over 32. I can reduce it to lower terms. Why I'm doing that? Because I can. And also I like simplification. I'm not going to use big numbers. I'm trying to simplify everything that I do have around my board. Why I keep a 3, why I don't have 3 plus 1 subtracted by 1 plus 2 subtracted by 2, why I don't have them, because I'm looking for simple things. That's why the way that we are doing it right now, you just try to find the simple things.